example to graph the exponential decay function. The reason that we know it's a decay function is because our b value is a 1/3, which is between 0 and 1, so that makes it a decay. I notice we have this x minus 2 and this plus 2 on the end. Those are our shifting numbers. The x minus 2 is a horizontal shift. Remember that the x is tricky, so it looks like we should go in the negative direction, but we're going to go in the positive direction 2 spots. And then the plus 2 is going to go up 2 for our vertical shift. So we want to do a table of values for our function without those shifting numbers, which is going to be y equals 3 times 1/3 raised to the x power. We can do our -2, -1, 0, 1, and 2 numbers for our table. So again, we have to evaluate this exponent part, the 1/3 to the x power, and then multiply by 3 in the end. Order of operations, we do the exponents before that multiplication. So 1/3 raised to the -2 power. Now the trick that we did in class, there's a few steps I'm skipping over, but in the end we end up with a 3 squared over 1 squared, which is a 9. So I just flipped the fraction, and then the exponent went with the top and bottom, and now the exponent's positive. And then 9 times the -2, oh sorry, no, what is it? Times 3 in the problem. 9 times that 3 is 27. So a 1/3 to the -1 power. I'm going to flip the fraction, 3 over 1, both raised to the first power, which is just a 3, times the 3, which is 9. 1/3 to the 0 power. Well, anything raised to the 0 power equals 1, and then times that 3 out front is a 3. 1/3 raised to the first power is just 1/3, times the 3. A third times 3 is 1. And then 1/3 raised to the second power, we're squaring the 1/3, so 1/3 times 1/3 is really just 1/9 times that 3, which gives us a 3 over 9, which reduces to 1/3. So here are the points we want to plot before shifting them. We're going to plot these and we're going to shift. So -2, positive 27 is way off the graph. We can't even get that. -1, positive 9 is going to be right around there. 0, 3, 1, 1, and 2 and 1/3. So we have 4 points that we can work on shifting. Now we're just going to take each one point by point and shift 2 to the right and 2 up. So if I start down here, I'm going to go 2 to the right and 2 up, and here's my new point, and I'm going to cross off the one I just did. So 2 to the right, 2 up, cross that one off. 2 to the right, 2 up, cross that one off. This one up here, 2 to the right, 2 up, I mean that's putting me way up there, but at least now I have that point. Before I do my graph, I'm going to draw in the asymptote. Anytime we have a vertical shift, our asymptote, which is always at 0, it actually shifts with the graph. So it will shift up 2 spots and be up here. So that gives me a nice line, a nice guide for doing my graph. So we come down here, and then it's just going to curve and level off right above that asymptote. So let me erase my work down here for a second. Now when it's asking us for the asymptote, that's the line that we just drew. We want to remember always to use the correct notation. It's a horizontal line, so we're going to say y equals, and it's up at 2, so our asymptote is y equals 2. Domain on these functions, we're able to plug in anything for x, the negatives, the 0, the positives, so all real numbers. The range, looking at the graph is pretty helpful for this one. It will be all real numbers, but as we look at the graph, we notice, range is talking about our y values, that we don't have any of our graph down in this area down here. Everything is above this line at 2, so we're going to say our y's are all greater than that positive 2. It's not going to be greater than or equal to because that's an asymptote, so as we curve down here, we actually never will touch it. We'll just get closer and closer and closer to it. So we are greater than that 2. And there is a decay function.